Okay, two new quadrilaterals today. We're going to start with parallelograms, and after we're done with parallelograms, we're going to move on to rectangles. And you probably know quite a bit about these figures, but we're going to go a little bit more in depth on them and use some of the ideas that we've talked about already. Okay, so that's a parallelogram. What is it? Oh, in case you can't see, if you look at a monitor, those are little arrowheads. What do the arrowheads mean? No, they're parallel. Because it's a parallelogram. So, what's the definition of a parallelogram, Scott?
A four-sided shape where two of the sides are parallel. The one side is parallel to the opposite side.
Just one side is parallel?
And the other side is parallel to the other side.
So the opposite sides are parallel?
Yeah.
Yeah. And you just said a shape, right?
Yeah.
What kind of shape?
A rectangle square.
No.
A quadrilateral.
It is a quadrilateral. Okay. So all parallelograms are quadrilaterals, but not all quadrilaterals are parallelograms. Okay. I got it right there. Because it's a parallelogram. Both pairs of sides have to be parallel like you see in the diagram. Okay, now the fun part. What else is true about that yellow parallelogram? So that's the definition. What we want to talk about now are the properties. What else is true about that thing? Wow.
All the interior angle add up to 360.
Ooh, nice. Okay, so let's make this A, B, C, and D. Angle A plus angle B plus angle C plus angle D equals 360. Good. What else? Go ahead.
ADBC. What? Two. How to say this?
I don't know.
Like AB add up to 180. Then BC.
Angle A and angle B add up to 180.
Degrees.
What's the fancy term for that?
It's a linear.
Say what? What meal do you eat after lunch?
Oh, supplementary.
Supplementary, correct. Okay. What about angles B and C?
It's also.
Or what about C and D?
It's also.
And D and A?
Yeah.
Okay, so can you generalize that? Because I don't want to write this 4 times. What's the relationship between angle A and angle B other than they're supplementary? What other kind of angles are they? Rosemary?
They're linear pairs.
No, gotta be next to each other, be linear pairs.
But they are on the line.
Not by our
They're the two on the
definition.
line.
They are on the line,
Oh, let's see.
yes.
Oh.
What general statement can we come up with to say that A is supplementary to B, B is supplementary to C, C is supplementary to D, D is supplementary to A, Brody? Are you answering that question or you have something else for me?
A equals C and D equals B.
Say again, I'm sorry.
A equals C, well, angle A equals angle C, and angle D equals angle B.
Oh, that's something different. We'll come back to you in a second. I'll make a note of that. Whoops. Okay. We'll come back to that. We're still trying to deal with Bow here. Because we don't want to write 4 different phrases, and we also don't know that every parallelogram is going to be labeled A, B, C, D. It could be X, Y, Z, Q. It could be a lot of different names. How do we generalize what he said into a sentence that will apply to all parallelograms? In other words, if I get rid of this, and this, and this, and this, how do I say that this angle and this angle are supplementary? What kind of angles are those? Maybe it's easier to see this way. hold on. Let's get rid of this. What about these angles? What kind of angles are those?
Same side interior.
Nice. Same side interior angles. I didn't expect you to be so excited about that, but thanks for the support. Same side interior angles. So these two angles are supplementary, yes? These two angles are supplementary. These two angles are supplementary. These two angles are supplementary. By the way, Brody, let's jump over to you now. How would you describe those two angles? Other than the fact that they're equal, which they are. In other words, you hand this parallel, you're sitting at the dinner table tonight, eating some dinner, and you pass a parallelogram up, you throw a parallelogram out on the table and you say, oh, by the way, you know in a parallelogram, blah, blah are congruent. How would you describe those angles? See what I'm saying? You could point to them. Kitty corner. It's not horrible, but I just don't know how to spell it. And I don't know if that's a solid. Okay, let's go with it. I don't know. Kitty corner.
Nope.
Kitty.
Forgot the J.
Oh no, it's here. Kitty corner. Angles are congruent. Does that work for you, Brody? You started this mess. Do you know what kitty corner means? Oh. Okay. Hold on. That doesn't work. So how do we describe those? Rosemary.
Are they alternate interior angles?
No.
Oh.
Ava.
Vertical?
Nope.
Do diagonal from each other.
Diagonal. We're getting warmer. I don't want to use that word because diagonal means something else, which I'll come back to in a second. But you're on the right track.
Opposite.
Opposite. Brody, you okay with opposite? Excellent. That takes care of this business, but we still haven't resolved Bao's problem. How do I describe those two angles? They're not opposite each other, they are?
Same side interior.
That would be if we were just talking about two parallel lines cut by a transversal. You want to stay with that? SSI angles are sup. Sup. Is that okay, Bob?
Wait, maybe two points on the same line.
You don't like this?
No, it's good.
So we're going to go with this? Or you want to change it? Does everybody understand what that means? No? Oh, then we got to change it. Eraser. So we're back to the question again. What's the relationship between those two angles? Ready?
Parallelogram angles that are on the same line are supplementary, so angles or points.
Parallelogram angles that are on the same line
Yeah.
are supplementary.
Because A and
I don't dislike that.
it's like long, but A it's like it's a long ways.
All right, let me write it down.
A and D are.
Oh, by the way, symbol for parallelogram, surprisingly enough, is a parallelogram. Parallelogram, angles on the same line. Can we change line to side?
Yeah.
Oh, that's horrible. I mean, my writing's horrible. Your definitions. Amelia, does that make sense? Angles in a parallelogram that are on the same line are supplementary. Or same side, sorry. So if I take this side, the angles that are on that side are this angle, and they have to be supplementary. Make sense? Everybody good with this? Let's roll with it then. Beautiful. Okay, so what do we know? We know the opposite sides are parallel by definition. We've established that the angles that are on the same side are supplementary. We've established that the opposite angles are congruent to each other or equal to each other. What else? Let me clean up some of this mess here. You have all this, yes? Yeah, okay, good. I'm going to put the labels back in there so we can discuss that. A, B, C, D. What else?
Is angle AB equal to angle DC? I mean, a line AB equal to line DC.
So close. Clean up your language.
Segment AB?
There we go. Is that side congruent to that side? Yes. Is this side congruent to this side? Are all these sides equal? No. Okay, so summarize that in a general statement, Karen.
Opposite segments are equal.
Beautiful. Just a small tweak there. You want to go with segments or sides? We can do either.
Sides.
Sides. You like sides better? Uh-huh. Beautiful. One last thing. We're going to come back to what Dayan said, and that is he used the word diagonals. Here's a diagonal. Here's a diagonal. What do you notice about those blue diagonals, if anything? Are they equal? No, no. Diagonals are not congruent. What's special about that point, which we'll call J?
Just the center.
Be more specific.
It's the center of the parallel.
It might be. Go.
Is this the origin?
No, because it's not on a coordinate plane. Anything else?
Is it the central?
No, triangles have centroids, not quadrilaterals. We don't want to go there. That would be,
Yes.
that's a scary rabbit hole you're proposing to dive down. Right.
Is it like the midpoint of the two?
Lovely. Diagonals. My handwriting. Okay. J is the midpoint of both diagonals. So if we want to mark this up, then we have this is equal to this, and that is equal to that. Excellent. We're good. Just because it's going to come up in problems, let me ask you another question. What's the relationship between this angle and that angle? Yes.
Alternate interior.
Which makes them
The same.
beautiful. What's the relationship between this angle and this angle? Is that it? Is that your car alarm going on? Yes?
Is it the same thing?
Same thing.
Alternate interior.
Alternate interior angles, they're equal. Okay, so we have a bunch of congruent, and we could do this the same thing with the angles over here. We could do the vertical angles in there. We could do the vertical angles here. So we got a lot to play with there. All right, so let's see how you did. We got opposite sides congruent. We got that under control. Yes? Great.
Yeah.
We've got opposite angles are congruent. Got that under control. Perfect. You guys are killing it. Oh, there's a picture. Great. Let's move on. I used the word consecutive angles. We used, what did we use? I erased it.
SSI.
We used SSI angles. Same thing. We have the diagonals bisecting each other. Fancy way of saying that that middle point is the midpoint of both of them. I don't care which method you want to use, but we're good on that. Hey, there's a picture of that. Isn't that lovely? Beautiful. Okay, solve that problem, please. Don't be bashful about firing up those calculators. Hi. How we doing? Start. Okay.
A and C.
Come on.
I actually played. Yeah, also you.
Don't rate on it. Just be polite. What? You want to fight when? Now? I don't know. We'll find out. Billy's going to share with you. Bring back that with you. Okay. Go. Show us what you did. Write nice and big. It's one of the things you got to learn. Oh, that's fine. I'm going to talk while you're working. Is that okay?
Yeah.
Boom. Sets the angles equal to each other. Why? Because we already know that the opposite angles in a parallelogram are congruent. Sets up the equation, solves the equation, and gets x equal to
27.
shh, 27.
Okay.
Good. Not the answer to the question. The question wants to know how big is angle D as in donkey. So she's plugging and chugging. Finds that angle A is 99. Finds that angle C is 99. That's good, so that checks out. The opposite angles are in fact congruent. Hot diggity. Now bring it home. 180 minus 99 is... Oh, you broke it. Holy smokes! How did you do that?
Wait.
Oh boy. That's all right. Just scratch it out and write it in there. We know it. That's a big fat 1. 81 degrees. Well done. Let's give it up. Huh? See a little part on the front of the board where you can stick the pen? Down at the bottom. Little pen picture. Nope, nope. Over to the left. Left. That. Oh, nope, nope. Little more. Little more. Nope. To the right. To the right. Nope, 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 nope. On the bottom. See the little graphic in white at the bottom? Oh, you're right in front of it. And little. Yeah. Yeah. Oh, let's give it up again for finding the man again. Well done. Any problems? It is possible that my picture might not match my angles. We've talked about this before. if, for instance, she found that, did all the math, and found that angle C was 81 degrees, don't trust the picture, trust the numbers. I may draw a parallelogram where a calculated angle is acute, but the picture is obtuse. Okay, make sense? We're good? Well done, excellent. Now let's do some coordinate geometry. So, I have these 4 points. We're going to put those on a coordinate plane. And I'm wondering, is that a parallelogram? Okay, so I happen to have a coordinate plane here. And I'm going to plot these points. I'm going to assume that you can all plot a point. R. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh boy. S. S. T. 8, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Stop it. T and U. 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. U. Yes, it looks like a parallelogram, but never trust a picture. What I would like you to do is figure out how would you determine if that figure, RSTV, raccoon, snake, turtle, viper, is in fact a parallelogram. Go. Question or answer? Hold on. Sorry for the interruption. One thing we want to do is, I don't really necessarily care about the answer. What I care about is how many different ways can you answer this problem? Carry on.
Oh yeah.
If all the lines are good, that's always it. Well, shape that we talk about, or is it
That S word you just used, what is that?
Oh,
I don't know what
that's
that
it,
is.
but like, if all the sides are equal, is it the?
What's the difference between a square and a
parallelogram?
Maybe if all the sides are equal to each other, would it be a parallelogram?
And it's where all angles are the same.
Bite.
Good.
Go.
one of them is not. We find one of them.
Just make triangles.
Oh, just make triangles.
Just trigonometry.
That's a V.
Yeah, that's it.
Oh,
First
thank
of all,
you.
you find the
Yeah.
I have trouble with my letters, that's why I went into math.
No, slope's easier. Slope is the same.
No. Find it from R to T and then we take the sine of that. Yeah, it's just
We check if the slope's the same, if it is. then
All the
how
slopes
we
are
check
the
it.
same. It's just
Wait, how will we do the distance from R to T? We find the distance of all of them, see if they're equal, and we try to use trigonometry if the angles are.
But if they
are
are right,
rough.
but they are right.
Both sides, right?
No, we can't.
Both sides.
In the essence of time,
We know, like,
Dude, that is.
because I still want to give you time to finish your hierarchies before you leave today, let's talk about different ways to do it. So, ideas. Scott.
You can find the slope with R and S, and then the T and V, and see if they match, and the slope of S and T, and R and V, and see if they match.
Method number 1, slopes, which is also a way to check for parallel. Good. What else could you do? Dan, what did you say?
So what I did was, so for example, 2 points R and V, and I check if the difference in the x coordinates are the same with the difference between S and T, and they were the same.
That would be slope. right?
No,
Well, that's what you would get if you check the difference in the x coordinates and the difference in the y coordinates would be the slope. Rise over run, rise over run. What else could you do? Go.
We can find like two angles on the opposite to see if they're equal.
Ooh, you could find angles. You could compare angle T to angle R, see if they're equal, and compare angle S to angle V. How would you find those angle measures?
Yeah, that's what I'm thinking about.
Yeah, that's a problem. Can't do that yet. Later. Other ideas? David?
You can check the length of the sides, the distance between the points.
Length of sides. Oh, number 3, I forgot angles. Angles. Okay, good. What I would do personally is I would use my distance formula. It's quick, it's clean, it's nice and easy. I would find the length of RS, the length of VT, the length of ST, and the length of RV. Plug and chug in the distance formula and check to see if the opposite sides are congruent. Any other ideas? Okay, there is one other, and that is, if it's a parallelogram, what's special about that point? It's the midpoint of both of the diagonals. Calculate the midpoint of SV, calculate the midpoint of RT. If it's the same point, it's a parallelogram. Midpoint of diagonals. Diagonals. Okay. Good. Brody, a question?
No.
Beautiful. Just waving your hand in the air like you just don't care.
Wouldn't the midpoint of two diagonals on a square also be?
I don't know what that word is you just used.
For goodness sake.
I have trouble with that. Okay, let's skip that. Let's skip that. I think you got this under control. We talked about that. You guys are okay. Rectangles. Let's get rectangles done. Abby, what's a rectangle? I got one for you. It looks like. Oh no, I didn't. Okay, never mind. Thanks, Abby. I went a little clicky crazy there. I thought I had a picture of one. A rectangle is a parallelogram. Okay, so remember, a parallelogram was a quadrilateral that yada yada yada. Now a rectangle is a parallelogram with 4 right angles. So let's go back to the dog/golden retriever relationship. We all agree that all golden retrievers are dogs, yes?
Yes.
Okay. Is there any property of a dog that a golden retriever doesn't have?
No.
Sure.
Yeah.
Let me ask my question again. I'll ask the easier question first. Is there any property of a golden retriever that a dog doesn't have? I think that's the same question I asked. Is there any property of a dog that a golden retriever doesn't have?
Like the dog can be like different types.
Right.
Maybe like brown fur, like it doesn't have fur at all. I don't know about golden.
Is there anything about a golden retriever that you can list that isn't true about a dog?
Well, not all dogs are golden retrievers.
Right, but that's answering a different question. Is there any property of a golden retriever that isn't also true about dogs?
Colored fur. Golden retrievers have them, most dogs don't.
But it's still a property of a dog, right?
The answer's no.
My point being is that everything that's true about a rectangle, sorry, I said that backwards. Everything that's true about a parallelogram is also true about a rectangle. But what makes a rectangle special are those 4 right angles. Okay, I thought I had a picture of one in here somewhere. Yeah, so that's the stuff we already did. Oh, there it is. There's a rectangle. Okay. Big difference between a rectangle and a parallelogram, aside from the 4 right angles, is that the diagonals are congruent to each other. They are not congruent in a parallelogram. Okay. All right, we don't need examples here. You can do this. Boom, boom, boom. Okay, get examples. Make sure we got everything. Okay, get there. Oh, we're done. Good. Okay, that was quick.
Yep.
I understand. But the only difference between a rectangle and a parallelogram is that rectangles, two things. They have 4 right angles, and the diagonals are congruent. Everything else is all based on the parallelogram. And from this point on, almost everything we talk about is also going to be a parallelogram. So you can see where this is going. We're going to talk about some other quadrilaterals, and eventually, you're going to create a hierarchy for quadrilaterals. And that's where I continue to bring up this idea of whether or not it's part of the other groups. You know, does a parallelogram belong on top, or does a rectangle belong on top, et cetera, et cetera. Okay, good. 20 minutes left. In that 20 minutes, you can start on the day 2 homework, or if you haven't already done so, finish your hierarchy. That hierarchy that you did with your partner is due before you leave in 22 minutes. Okay, go.
Sorry. We're gonna get sterilized.